Hi everybody. I know, you read the title and you're here to shame me for ever having the audacity to buy one of these green tools from the orange store. I assure you, I own real tools, such as Craftsman, Klein, SK, Lyle, lots of Craftsman, Ingersoll Rand, Hobart, Baldor, Crescent, Armstrong, Husky, Mitutoyo, some gear wrench, Nerf. But this thing, it works for me, for the most part. I don't have much property. I don't have many leaves to clean up. It's a lot of hard surfaces, the driveway, sidewalks. So this thing works really well, when it works. I get why people hate Ryobi. I understand. I get it. I like a lot of the Ryobi stuff that I have. I have their drill and driver. I have the weed whacker. The thing works good for me. This thing, when it works great. It's not working. And we're going to discover why it's not working. This is going to be my third time doing this to this, and we're going to go over the shortcomings of their engineers and how it boggles my mind. How do you make a mistake like this? But we'll go over it. Let's get into it. So the problem I'm having with this thing is that no matter how you squeeze the trigger, if you just squeeze it down like you're supposed to be operating this thing, it does not go into full power. Here I have a full battery, freshly charged. It's their green top plus battery, so there's no reason why this should be slow or anything. And you hear that I can get it into high gear, but it doesn't stay there, and it doesn't just go into high. So we're going to take this thing apart, and I'll show you the fix for it. Unfortunately, the fix is only temporary, but someday I might figure out how to put something different in here and make it permanent. Okay, so to take this apart, you need a T15, and I'll be using a screwdriver from a different orange company, the LTT ratcheting screwdriver. And all the screws are on this one side here. So we just have all these screws here. Oh, there's two in the back too. Just start taking them out. Unfortunately, I have two ones in deep holes here, and I can't find my long socket for this, but luckily I have this snap-on pocket screwdriver that is the exact size to fit into a T15 blade-wise. So I could just take these two out with this. You just have to put a lot of downward force and turn, and this will not strip out a screw. Take it right out. Make sure it's set good, a lot of downward force, and it'll come right out. So that's all of them on that side. Now we have one back here. And we have a couple facing back. Luckily, they're all the same screw. Right, now this just clamshells apart. Now we have all of our inner workings. So, as you can see, it's pretty simple inside. Not much going on here. You have a battery connector, you have a switch, goes to a motor. Should be really simple to engineer something like this. This should not be able to be screwed up easily. But let's get into this switch here. I don't know who made this switch, but they need to go back to school. Okay, now this switch comes apart with some small Phillips. And it's just hope and a prayer to get it apart. You have to just pry it open with these little locking tabs all around it. So like I said, the switch has been opened twice already. And amazingly, I have not broke it. Not broken any of these locking tabs. But having said that, I'm probably going to do it now. Now let me go around it, the other sides. There you go. And this one with the diode in the way, pain in the ass. Might be able to not do it. Nope, that's going to be a problem. I have to get something in there to open that. Oh, the diode has come unsoldered. That is going to have to be fixed. So here we see we have a motor controller. Whenever you're on one of the low speeds on this, you're using the motor controller and the MOSFET here to slow the, or run the motor at a slower speed. But then if we get into this farther, you'll see that there's a second set of contacts that put this into full speed. And that's the contacts, that's the problem that we have with this. So there's a spring in here you got to worry about flying. It has a very thin circuit board too, you don't want to break it. Take it out nice and slow.
One eternity later.
There we go. End piece to the spring, and the button with the sliders on it. And there's our problem. Look at those contacts. So now this is where I take issue with this device and this engineering. This is a high amperage device. This takes a lot of battery amperage and puts it through to a motor to run it fast. And they used contacts that don't snap on and off. They don't snap together when you push it all the way down. They don't snap apart when you release the trigger. They slowly, as you get closer, they will contact. And then when you start letting go of the trigger, they will slowly let themselves go. That causes arcing. That causes this issue that we see here. Look at these contacts on here. Look at this one. This is a good contact. This is what it's supposed to look like. And look at this one. It's burnt. It's arced. It looks terrible. This is the button. This is the slider that goes up and down and connects that. Look at the contacts on the wires. Look at that. Burnt. Crispy. Contact in here. Look at this back of the circuit board where it's been arcing. There's arc tracing all over it. Come on, Ryobi. You have to do better. This is bad. This is bad engineering. It's bad practice. This is in something that you made probably millions of. And this is the type of switch you make for it? This is unbelievably bad. But I can fix it for now. Unfortunately, there's no permanent solution to this. I can't figure out, well, maybe someday I'll really look into this and figure out how to shove a micro switch, a real clicky micro switch that can handle this amperage into here. Actually, I might wind up, there's space in here, I might wind up doing a relay. I'll use your crappy piece of junk switch to turn on and off a relay that will handle all of this, because this is unacceptable. This is unacceptable engineering. What in anybody's book? This is so stupid. I guess this is why everybody hates Ryobi. Stuff like this right here. But let's get into fixing it. So to fix this, we need to take a needle file and we'll just clean off the contact. Now we're wearing away some material, but we want to get all the pitting out of it. This is just a little copper dot on top of here. And as you're shaping it, you want to try to make a dome shape to it. You don't want it completely flat. You want a somewhat dome shape to it. That one looks pretty good. Okay, so I wanted to bring this one underneath the microscope so you can actually see what has happened to this contact. So that is a good contact. That is what one of these contacts is supposed to look like. A nice dome, maybe a little bit of wear on it, and then this is the one that's actually carrying all the current. This is the one that just goes to the motor, and look at that, it's melting copper. There's molten copper on there. That's how hot the sparks are that are across this. Well, now they're concentrated into tiny little dots because the whole thing is just destroyed. And then I don't know how many more times I could fix this because the switch itself is just going bad. Jeez. This thing gets so hot it routinely melts into place. See, it's broken. Is it broken here? Yeah, it's broken on both sides. Might have to try to glue that, I guess. But let's see if we can get this cleaned up. Maybe I could use this for at least one more leaf season. If anybody knows where I could get these little pads, that'd be great. Maybe I could just get a whole new switch. Wow, that's bad. I don't even know if this is going to go back into this straight. I guess that's pretty much as good as I could hope for. Okay, there's just a bunch of scorch mark on the board itself. See if we could clean that up a little bit. Alright, so that's clean. That got cleaned. So this is ready to go back together, and hopefully it'll last one more season. Let me get some electronics cleaner. Some electronics cleaner on the Q-tip, and we'll just scrub up everything on here. All the contacts. And now we're ready for reassembly. Okay, so now reassembly. This is going to be difficult to film because I need to have a bunch of fingers on a bunch of things at the same time to get this to go back in here. Holy shit, it's back together. God damn. What the f... Okay, let's get out the garage soldering iron and we can fix this, this broken solder joint here. Okay, now that we have the garage soldering iron out, we'll just put some new solder on these points for the protection diode. There you go, that's soldered up nice. Now we can put this thing back together and see if it's working. Okay, putting it back together is just the opposite of taking it apart. But you have to make sure you tuck all of the wires back into their little nooks that they go through, or else it won't close right. All of these wires have to go into their nooks like this. Mosquito flying at me. Since those crazy rains that we've had the last couple days, the mosquitoes have gone nuts around here. So while I'm holding it, I'll get one screw in the front here, because it does want to come back apart, so get a screw started in the front. Okay. Let's go for these deep ones that I need to use my flathead. go. You just put all these screws back. And this should be good to go, I hope. I do believe I did not have to take these out. No need to take this thing off of here. All right. So now if this goes all smoke, on video. Fully charged battery, and there you go. So because of this terrible design that this thing has, I try to act when I use it as if I'm clicking it on and off. I try not to go slowly from low to high. I know about where the area is, so I try to like snap it in and snap it out so that it doesn't burn like this, like they should have engineered this thing to do to begin with. This is terrible engineering, terrible design. Maybe someday I'll do a video of trying to upgrade it to a relay in place instead of this, this stupid switch. But thanks for watching.